Hi all. Today we are going to perform an experiment called impact of jet. The aim of the experiment is to find out the jet force exerted by a moving fluid on surfaces. So, to study the force exerted by a moving fluid is very essential when it comes to the application of turbo machineries. So, we all know that when a solid ball strikes on a surfaces, it nicely rebounds. Or when it comes to fluid, it doesn't rebound, but rather it moves tangentially and it sweep out surfaces through tangentially. So, the impinging angle of the fluid is an important parameter for the force, jet force. First, let us start with familiarizing the equipment. The equipment consists of a clear acrylic cylinder. Inside the cylinder, we can see the jet and the impact surface. That the surface is hemispherical in shape. Water can flow from the bottom vertically upwards through that, and there is an surface. The surface is hemispherical in shape, and the surface is attached to a stem, and a weighing pan is also attached. Towards the top of the cylinder, we can see a pointer with which we can, towards the top of the cylinder, there is a pointer. It helps to uh, locate the equilibrium position. Where in the weighing pan we can add mass and we can counterbalance counterbalance the force with non amount of masses. So towards the top of the cylinder there is a hole. It keeps the pressure inside the cylinder in atmospheric pressure. There are outlet veins in the bottom of the cylinder. Through it act as an outlet, and there is a flow control valve with which we can control the flow rate of water coming through the jet. And this equipment is called the rotameter. The rotameter will give the corresponding flow rate for the particular valve opening. So it is measured in liter per hour. So now let us start with the experiment. Uh, Switch on the apparatus, and then slowly control the flow rate from the pump. As you can see that the water is started coming at through the jet, and you can also see that like the flow rate is getting increased. So now I have fixed the flow rate at 600, and you can see that the surface went up and it hit the top part of the cylinder. Now I am going to fix the flow rate at 800 liter per hour. Top end of the orange color float will give us the corresponding flow rate. So the corresponding flow rate. So now I fix at 600, 800, 1000. So now I fix it at 800 liter per hour. 800 liter per hour. Now you can see that. No, now the flow is happening from here, and it coming through this pipe, and it coming inside from the bottom of the water, from the bottom of the cylinder through a jet. It it shows that the force exerted from the jet is more compared to the weight of the surfaces. So here we will be uh, considering the dead weight of the stem and the weighing pan and the surface's weight. So we can counterbalance this force, or we can equate this jet force by adding non-masses in the weighing pan. So for that we have a non-set of masses that we will be utilizing it. Now you can see that the jet force is the water jet is exerting some some force on the surface. So I'm trying to give a try with my hand. I'm just applying some force from the top, and you can see that with some amount of force I can counterbalance this the jet. Yeah. So, we have got a different set of masses, different set of weights. Uh, each weight is marked over there, like this is 100 gram, and this is 5 gram, and this one is 3, this one is 3 gram. All these small weights helps to fine tune the uh, mass, fine tune the weights. Okay, so 100 gram. So now the flow rate we kept it as 800 liter per hour, and the water is coming from vertically through the jet from vertically upward from the bottom of the cylinder, and you can see that since the jet force is since the water is exerting a force on the surfaces, it move upward. In order to counterbalance that force, we will be adding non amount of masses to the weighing pan. We will be adding a small amount of weights one by one, and we will try to find out an equilibrium position. We can see that I add few, like I added 10 gram, also 17 gram, and it is not sufficient to counterbalance the jet force. So I'll be keep on adding small amount of weight, and at some point we will be getting the equilibrium. Yes, now we can see that the added weight is more. That's why the weighing pan is moving down from the equilibrium point. Now we need to adjust the weights on a trial and error way. Now we can see that the weighing pan is somewhat, now we can see that the weighing balance is at a position, it attained the equilibrium position. So these non weights, so all these weights, this total amount of weight consists of, the total weight is counterbalancing the jet force. So we can sum up these masses, so we can sum up all these masses to find out the equivalent force. So we have performed the experiment from the flow rate. We will be able to calculate the theoretical force, and from the non masses we will be counterbalance it. So we will get a comparison, or we will get a correlation between so we will get a comparison between the theoretical and the experimental value, and then we can find out the water force. So we have performed the experiment, and from the flow rate available we will be able to calculate the theoretical force, and we have the known masses with us for the particular flow rate, and then we will be getting the experimental, we will be getting the calculated force through the experiment. So we can find out the coefficient, the ratio between the theoretical and the experimental force, and with which we can find out the force for corresponding flow rate through this particular experiment.